Hey everybody, it's Jeff. Welcome to CS161A. We are in Module 10. We are in the last week of the content for the course. We're going to recap functions. We're going to spend a little bit of time on a function that I'm going to demonstrate around doing some error checking. And then I'm going to show you some more advanced features around functions, reference parameters, function overloading, default values or an optional parameters, a couple things like that. This is all in chapter 9. If you look in chapter 9 here, not as much stuff here, right? Not as many sections here. We're getting in some pretty advanced topics here as we wrap up this class. And as usual, we'll walk through the code, and the code, if you found the video, you've probably found the code. Just a logistical administrative thing that I want to mention here as we get to the end of the term here. The deadline for any late, missing, resubmitted work is the Friday before the final exam period. Okay, so depending on when you're watching this might be tomorrow, might be now, right? It might be next week or whatever. The Friday before the final exam. There are no exceptions to that. It takes time to get everything done and get everything graded here. If we are before, if there's stuff that you've submitted prior to that deadline and it hasn't been graded, let me know. I may have missed it. It's possible. But don't read anything into that. If I missed it, just let me know, okay? So we can get it graded here. All right, let's begin here with a recap of functions here. So we're going to recap our basic function, returns a value, and has one or more input parameters. By the way, that's true of the main function as well. A little bit outside the scope of the course. So we're not going to talk necessarily about the parameters that main can take, but it's true for main as well. That's why you see it's declared as an int here. Okay, so we're going to create a double precision floating point value function called Pythag, which is going to calculate the Pythagorean theorem result, double Z. For those of you that need a refresher on what the Pythagorean theorem is, if you have a right triangle, your two sides, x and y, are the two sides of the sides that are perpendicular to each other. Z is the slope side, which is the longer side. And so the formula for the length of the slope side is equal to the square root of the two perpendicular sides, right? So Z is equal to the square root of x squared plus y squared. So that's our Pythagorean theorem here. Let's go ahead and I'm going to declare two variables double up here, and I am going to enter those, and we're going to print out the result. Okay, 3 times 3 is 9, plus 4 times 4 is 16. 9 plus 16 is 25. That's a perfect square. So this is one of those cases where where you can have a triangle, a right triangle, where all three values are integer. More often, you might have something like that, right? We can enter floating point values and get our result and so on. Okay, so that function is working. It's doing exactly what we want here. What I want to do here, before I jump into some of the other functions, the features of functions, is I want to demonstrate the use of functions along with some of the other stuff that we've been covering to create a pretty complicated function that's going to do some error checking on an input floating point value. Okay, so we just did this assignment, right, where you did the weighted grade calculation, and I had you make sure that the input grades were between 0 and 4, and the number of assignments were between 0 and 10, and I had you put that error checking inside those functions, right? So we're going to do something similar to that. We're going to do this, it's going to be much more complicated here. So there's a little bit of a detour here, because it's a good way to connect some things together here as we wrap up the course. Okay, so here's a function. I wrote that prompts and tests for a valid floating point value. And in this case, it's double precision is what is returned. You could change it to be, you could change it to just be a float if you want as well. Okay, I do not check for the precision itself. Like I don't check to see if the number is too big or too small. And I don't check for scientific notation. Okay, the rules, here are the rules of what I'm going to implement here. Okay, I allow an optional negative or positive sign. Must have at least one digit. Must have at most one decimal point. Otherwise, must be all, okay. Otherwise, allowing for A and C, otherwise all digits only. I don't know why I was having trouble saying that. Everything else has to be digits, like you can't have an X inside of this number, right? Yeah, one decimal point only. Leading digit can be 0 only if it's the only digit before the decimal point, and we will demonstrate what's good and bad here. And trailing zeros are allowed, i.e. 3.00 is okay. i.e. 0, 1, 2, 3 is not okay. And 0 before decimal point not required, i.e. 0.333 is okay. Okay, and all combinations of all this stuff. Okay, lots of ways to do this. Okay, if we were in a 200 level class, maybe 161B, maybe. I could give you this as a exam question, and in a couple hours 10 of you would do this 10 different ways, and they would all be fine. Okay, so those of you that want, pause the video and go do it. That's awesome. Go for it. Save your solution. Send it to me if it's got something different than mine or doesn't work or something. If you don't want to do that, that's fine. Just follow along. It just occurred to me that it would be fun to, like, okay, pause the video, go do it, right? Some of you might. That'd be cool. Okay, so we're going to create a function called double input value double. Sorry, input valid double. Okay. The way I'm going to do this is I'm going to do this using an infinite while loop, where I'm going to ask the user to enter the value, and I'm going to declare that data type as a string. Okay, now the reason I'm declaring this as a string is because I have to check these syntax rules. And if I declared it as a double and I put 2 decimal points in it, it's not going to evaluate the right number. And so I'm not going to be able to do my error checking. So when you want to do error checking around the syntax of data versus just the value, you have to do it as a string. If you're doing just the value, like is it negative or not, you can do it as the data type, like you did for the weighted grades, right, between 0 and 4. Okay, so we're going to create this string. I also need a way to break the loop, right? And so I'm going to create a flag, and I'm going to call it val is valid. And inside the loop, I'm going to set val is valid to true. So I'm going to start off with good thoughts. All right. And then inside my loop, I'm going to say if val is valid at the end of the loop, if it's still true, I'm going to break out of the loop. Else, I'm going to say, sorry, not valid. Try again. And in that case, I'll jump back up here. Okay. Okay. I was going to do that first, but I'm going to keep going and I'll come back to the scope. All right. So now I'm going to change my code to call the function. Oh, what the heck did I do there? Okay, and I'm just going to return 0 right now because I haven't yet done anything. I want to, again, like I do throughout the class, demonstrate doing this incrementally. Versus, by the way, my function, if I look at, I have my fully written function here to the right, so I don't have to have it memorized. It's 247 lines without this up here. So starting here, the function is 247 lines. So I have another 220 lines to go. Okay, it's really hard to write 250 lines of code and get it to work on the first try. And even if you don't expect it to work on the first try, it's really hard to write 250 lines of code and debug it. It's a lot easier to write 10 lines of code, check, write 10 more, check, then check the interaction and keep going. Okay, so what we're going to find here when I run this is it's going to ask me to enter a value, and no matter what I enter, it's going to let me enter it. Right? Because val is valid is set to true. I enter it. If it's true, I break. So I enter my 2, and I get a result of 0 because I'm returning 0 in both cases. And so my Pythagorean theorem is gonna give me a result of 0. Okay? Don't worry about that just yet. The goal here is to get this function written so that I'll eventually return valid numbers here so that this guy will eventually work as expected. Okay. Okay, so let's walk through the steps that we need to do. So first, check if the first character is a Okay, I'm going to create an integer variable called index, and I'm going to initialize it to 0, and I'm going to check my leftmost character of my pattern, and I'm going to use the at function to check to see if it's equal to a negative sign or a positive sign. If it is, then I'm going to set index equal to 1. Okay, so what that does here is it basically, the rest of my checks will start at 1 instead of 0. because I know that position 0 is a negative sign or a positive sign, and I know that that's legal. Okay? And so, but must be leading character. Obviously. Maybe not obviously, but it is, yeah. So, okay. So we're going to check for that, right? Okay, once we've done that, now check the characters in order. We are looking for non-digits and more than one decimal point. Anything else, either of those, if either of these occur, our input is busted. Okay. I'm going to put a comment here because we're going to do that as well. Okay, we're going to do this in steps here. So in order to check the characters in order, we're going to run a loop starting at index, not at 0, but at index, which means we're starting at 1 if we've already established that position 0 has a negative or a positive sign. We got to check and make sure, we got to go through up to the size of our input string, one character at a time. So there's our for loop. You've written code kind of like this already. Okay, I'm going to put a default, a debug statement here to show that we're processing these characters one at a time. Okay, so if I run the code now, and I type 1, 2, 3, it shows me 1, 2, 3. If I type plus 1, 2, 3, notice it skipped the plus because we've changed index equal to 1. Same thing. Okay? I have to remember that every time I run the code, I'm inputting two things here, right? That's okay. We'll leave it. Okay, so we're going to run through the characters one at a time. We're going to first say if the character at the position is a decimal point, we are going to set a flag equal to decimal point found, because it's useful to know if we have found a decimal point, and that is false to start because we haven't found it yet. Okay. If it's not the decimal point, then we're next going to check to see else if we are not a digit of the character at position I. I always do this. Check my parentheses. 1, 2, 3. If it's not a digit, here's the first place where we're going to set our val is valid flag to false. Else, if we get here, what do we know? That the character that we're testing is a 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So we're going to take our num digits and we're just going to add 1. We found another digit. Okay, and I'll show you why we use that here in a moment here. Okay, so let's see what happens when we run this. Oh, I didn't declare it. Int num digits. Num digits equals 0. So if I enter 1, 2, 3, 4, 5, like that, it shows that I'm processing it. So far, so good. Let's try that. Oh, I guess we could put that in there too. So it says, sorry, not valid, try again, because these guys were non-digits. Okay, so that's where val is valid got false. So therefore this happened, and we jumped back up to the loop. We reset our stuff, and we asked for a new value. Okay, one thing we haven't checked yet, we haven't checked a few things. We haven't checked for that case, like a plus by itself. Like we got to have at least one digit. We haven't checked for that yet. Remember that comment is here. You've probably already figured out how we're going to do that. Okay, another thing we haven't checked for is this problem. Okay, so let's do this one next. Okay, so the way we do that is we've already established here that we're using this decimal point found flag. So if I find a decimal point, but I've already found a decimal point, then I can set valid is equal to false. Okay, and then I can set decimal point found equals to true. Okay, I could put an else and put this guy inside an else if I want, but it doesn't matter either way. If it's already true, which is what I'm checking for here in line 65, and I set it to true in line 68, that's fine, right? And so to me, this is clean. If my current, let's walk through these 5 lines. If the current character is a decimal point, if I've already found a decimal point, that's a problem. Otherwise, I've now found a decimal point. That's the pseudocode-ish for this. All right, so let's try. Okay, so that worked. What about that? Nope, doesn't like that. Doesn't like that. So that's okay, right? So that's working. Okay, this guy's easy. If num digits is equal to 0, if we have no digits, we're going to set this equal to false. I could test this right now. If I really want to be good, I'll test this. But I'm going to trust that these 3 lines of code look good. Last time I said that, I only had one equal sign there, and the thing didn't compile, right? So of course there's the Murphy law there. But this looks good to me. We're going to let that guy go here. And so let's now see, there's one more condition that we haven't tested yet. So we've checked that, we've checked that, we've checked that, we've checked that. We haven't done this. F and G are going to happen because we're not checking against those. But E we haven't checked for, right? So I can do this, and it allows that. And I can do that, and it allows that. Okay, so let's think about how we might check for that. We need the only allowed leading 0 pattern is 0 point something something, right? i.e. 0, 0, 1, 2, 0, 1, 2, 3, 4, 5 not allowed, and well, that's basically it, right? And so you only allow a leading 0 if it's the only digit before the decimal point. Okay, so the way we're going to test that, and it's interesting because I had written this one different way, and then as I was thinking about this, as I was getting ready here, it's like I'm going to try this a different way, but I haven't tested it yet. But I think it'll work, so we're going to try that right now. If you look at this here, if I just look for a pattern of a 0 followed by a decimal, if I look for anything that's not a 0 followed by a decimal point. Okay, and the way we would do that is we would say if the character at the position of index, right, which is either 0 or 1, if that is equal to a 0, and the character at the next position, which is index plus 1, is not equal to a decimal point. That's that guy. And that should be that guy. Hopefully my parentheses match. I always get paranoid. Then I'm going to say val is valid equals false. My first way that I did this, I scanned everything and I captured where the position was of the decimal point. It was way overcomplicated. And then it's like, that's not necessary. So if I try this, it doesn't like that. Doesn't like that. Doesn't like that. That works. That works. 0 point by itself works. Okay. What about with a sign? It's okay. That's okay. There's something about this code that worries me. If you looked at what I just did, I did a 1 by itself. And so that's this guy right here. Okay, so what happened here is immediately the left side of the AND returned as false, right? And the way the software is smart enough here to say, if this is false, I don't need to check this, because false ANDed with anything is always false. Okay. But if I do this, I get an error message. Okay, and if we were all together, I'd pause and say, why are we getting an error message, right? And the answer is because this left side evaluates to true. So then it says, I want to check the next character. But there is no next character. And so I get an out of range or out of bounds error message here. And if you don't test this case, and some of you who went and implemented this and now are coming back to the video, you're saying, crap, I didn't test that case. That's okay, by the way, right? Fess up to that, because that's good, right? It just shows you the importance of this. And this is a subtle issue that is interesting to show. Okay, so the way we're going to fix that is we're going to make sure that the length is at least, if the length minus index is at least 2 characters. Because if the length is only 1 character, then if it's a 0, it's okay. And if it's not a 0, it's okay. So now that works. Doesn't like that. That works, and that works. Okay, so you got to be careful when you're working with bounds. And whenever you do something like this, where you're adding to a position, you got to be careful. We are going to cover this in more detail in CS161B when we introduce arrays. Bound issues in arrays are really common. Going out of bounds in strings is really common. And when I used to teach CS201, which is the operating system class, it was always fun in Linux to show some C++ code where, based on how the code was written, if I knew the order of how variables were declared, I could type something in to actually create a vulnerability inside the system and actually do something that the user doesn't expect. And so bound checking with arrays and strings, super important. In this case, it gave me that error message, right? Because it said, hey, wait a minute, the string is only this long and you're trying to access the next guy. Okay? Yep, so that's that. I think we've covered it. So I think we've gotten everything. And like I said, I'm going to make a note here. The version of the uploaded code has a more complex way of doing this. And then in my code that I'm going to upload, note that the video, no, wrong spot. The video shows I already have that comment. The video shows a simpler implementation. Okay, so For those of you that are not watching this video and looking at the code, you'll see the more complicated version. I might encourage you to look at both. Okay, the last thing we need to do is if we get here to line 100, we've broken out of the loop, which means we've gone through all the checks. Our value is valid. So we should be good. And so we need to declare a variable, and I'll just call it val. And we need to convert the string called into val and return val. Can tell I always want to put my return values in parentheses. Okay, so now when we run this guy, I get my results, and it prints my result here. But I took out 4 sides. And I'm going to get rid of this guy because it's clutter at this point. Okay, it's good. Something like that. You definitely can have a triangle. It's kind of non-intuitive. You can have a triangle with a negative side, right? At least in our function, we don't do any error checking there. That's not in the function. We would have to do that. Like if we only wanted to allow positive numbers, we could add a parameter, which was a sign flag, for example, to only allow positive numbers, or we could do the check here and re-ask here. Lots of ways to do it. Okay, so there's our relatively complex error checking function, where we try to combine some of the stuff that we've covered here. All right. Notice here that I've declared variables called x and y here, but I've also declared variables x and y here. Okay. If I change the value of x inside my function, x is 2, right? Because what happens here is I get, actually, no, I haven't done it yet. Sorry. I'm ahead of myself. Okay, so there's my sides of 2 and 3. I need to put the print, I have the print in the wrong spot. Okay. X is 2. Okay, so I set x equal to 2 here. I call the function and I call it again. Those are the input values, right? But here is where I call the Pythagorean function. I pass in x, which is equal to 2. I do my calculation here, and then I overwrite x. But that overwrite does not make its way out here. Okay, we talked about this a couple times already. This variable x is a global variable. Okay, if I add another global variable, and we're going to keep both in there for illustration. So in this function, I modify both x and y, but x is a local variable. It's passed in as a parameter here. So if I modify x or y or z inside this function, it's like forgotten the minute I leave the function. It's gone. A, on the other hand, is a global variable. And so a reference to A is allowed, and it does update here. Okay, so this is, again, we've talked about this a little bit, and like another example where I'm doing that is right here, where the variable I is only valid and it exists only inside this loop. This is what's called scope, right? And if you have lots of global variables, and you name things and you forget what they're called, and you have variables that are closely named but use the wrong ones inside your function, you're going to have bugs. So it's really valuable to be disciplined about how you name your variables. It's really valuable to be use input parameters versus just relying on global variables, and that helps reduce those types of bugs that you might run into. Okay. Now I want to talk about passing values by reference, variables by reference instead of by values. So what I'm doing right here is I've declared two variables, x and y. I am going to duplicate this code, and I am going to rename these guys to A and B. And I'm going to declare them the same way. Okay, they're both of these blocks of code call the same function. In the second case, the variables I'm passing are A and B. I'm passing the values of those into these two positions, but inside the function they're called x and y. This is what allows you to use your function multiple times, regardless of what the input variables are called. Okay, and this is where, so if I can have triangle 1 and triangle 2 and triangle 10, whereas inside my Pythagorean, I just have x and y, right? Okay. In all of these cases, those global variables, those values are preserved, like I just talked about. You cannot overwrite them. But what if I do want to overwrite them? What if I want to modify my function? And so I'm going to create another function here. We're going to pass by reference. Okay, and before I explain what that means, I'm just going to show you what it does. If you've ever looked at complicated code, you've seen these ampersand symbols, and they probably confuse you. Okay, so let's try this. Okay, that's our first call. If I go down here, that's our first call. And there's our second call. So notice that our triangle got properly calculated. Again, another perfect integer triangle. 30 squared is 900, 40 squared is 1600. You add those together, the 2500, the square root of that is 50. Perfect square. Okay, but you can see A and B have been changed. Okay, but if you look back up at the code, well, I've changed x and y. Okay, what this guy does here, what this nomenclature does, and you'll see it written this way, and you'll see it written this way. I think the standard actually is more often that way. Okay, and what this means is instead of passing the value of that double into a variable called x, I'm passing the location of that space in memory as a double data type. That location can be accessed as a double data type. So if I want to read x, I get the value that's in that memory, but then I can override what's in memory by modifying it directly. And so even though this is a different variable, it's a gets changed because the function is referring to the location of a. Okay, pause, go back a few seconds and listen to it again. Pause, go back a few seconds and listen to it again. It might not click right away. It's not necessarily intuitive. Passing by value versus reference is one of the most confusing topics that beginner to intermediate developers have. For some, it just clicks. And others, it can be very, very confusing. So this is why would we care? Why would we want to do this? Well, there's a few reasons. One reason is that if I have complicated data structures and I can't just return a single value and I have to modify a bunch of things, that would be a reason. Memory optimization, managing the memory is a common reason. Dealing with more advanced data structures, which we'll cover in the next course, arrays, for example, you have to pass them by reference because you simply cannot, it's too memory intensive to pass large data structures as values into functions. So it becomes more and more intuitive as you develop over time. Okay, here's an example of modifying a pair of related values using pass by reference. So instead of doing this arbitrary thing, let me give you like a useful example, right? We'll stick with the geometry example. We're going to create a function called circle geometry. We're going to give it a radius. We're going to pass a reference value of area and a reference value of a circumference. Probably see where I'm going here. We are going to calculate the area. Remember, the area of a circle is pi times the radius squared. The circumference is equal to 2 times pi times the radius. Okay, we need to enter, sorry, I'm going to paste this in because I did this already. Got to get a constant pi in there with way more decimal points than we need. Where to go? Here it is. So now I have pi here. I don't need to return anything. I'm declaring this as a void, right? And so how do I use this? I'm going to write a loop, and I'm just going to go by threes. And I am going to print out circle geometry pi area A and C. I need to declare A and C first. I've already declared A, so I'm going to set it to 0. I'm going to double declare C to 0 because I'm going to pass these things by reference. Technically doesn't need to be declared, right? And then we're going to print out R equals area equals circumference equals and that should do it. Let's give it a shot. So now you can see for radius 1, my area is equal to pi. circumference is equal to 2 times pi. For radius equals 10, we could do this math, right? 10 squared is 100 times pi is about 314 and change, right? And so you can see that this looks like this is working. So this is a great way to modify variables through a function more than one versus just passing. If you wanted to pass these variables and do return values, you'd have to have two separate functions, one for the area of the circle and one for the circumference of the circle, which you can do, right? Very, very valid option, just difference based on your preference. Okay. We did an example of this last week. You might remember we did the least common multiple and the greatest common denominator from last week. Those could be combined in a function using passing by reference here. Okay. So I have some guidance here on pass by reference, right? I'm going to summarize this a little bit here. The question is why, right? The arguments need to be modified. Okay, so you might have a function that based on what happens in the function, the argument gets modified. Right? So for example, let me make something up. You have a function that's reclaiming disk space and you're calculating the amount of space available or something like that. Certain data structures, I think I mentioned this already, must be passed by reference. Arrays, for example. We haven't talked about arrays in class, remember? So we have not talked about arrays in CS161A. That's coming in CS161B, which I'm teaching next term. So might see some of you in that class here. And then large data types must be passed by reference. 2 and 3 are a little bit overlapping, but there are large data types that aren't arrays and vice versa. Okay? Do not get in the habit of using pass by reference as default. You will pay for that. You will create bugs that will be hard. It's really good habits to maintain scope and passing parameters. It's easier to debug. It's more maintainable code. Okay, but these are some examples where it makes sense. Okay, I got a couple more topics here, and then we're getting close to wrapping up. Looking at the time of how much this guy is, it's not too bad. I wanted to add a couple things because I didn't want this video to be like super short here. Okay. Okay, so what if I have a function and it has a bunch of arguments and I don't want to always pass them here? So for example, I want to calculate total seconds of elapsed time. And so I'm going to give you some example calls to show you what I'm talking about. So if I write a num seconds that calculates the number of seconds input parameters are number of days, number of hours, number of minutes, number of seconds. Okay, so you can see that this is 1 day, 2 hours, 30 minutes, and 46 seconds till countdown. I want to know what the total number of seconds are. Okay, but if I want to use this in multiple cases, and sometimes I only care about hours, seconds, and minutes. Sometimes I only care about hours, days, and hours. And sometimes I only just care about days. It would be convenient to be able to call my function like this. Right? Knowing that versus saying 0, 0, 0. Right? So let's see if we could figure out a way to do that. So I'm going to write a function here. I feel I can do this from memory here, but I'm going to get my notes up here just in case. Total time calculation int num seconds, int days, int hours, int minutes, int seconds, int total seconds equals 0. Seconds plus minutes times 60, right? Plus hours times 60 times 60. Some of you would just immediately just do hours times 3600, and that would be okay too. 24 times 60 times 60. Return total seconds. So I think that'll work. All right. If I run this, I get some error messages here. In 3 of the 4 cases, it's telling me that, wait a minute, I'm expecting 4 parameters, but you're only giving 3. I'm expecting 4, you're only giving me 2, and so on. So we're going to comment those guys out here. Run this again. First triangle, second triangle, bunch of other stuff, and you see I get my calculation here, 95,446. Okay, so now how do I get time 2 and time 3 and time 4 to work? And actually, there's even a time 5. I think that will work. We're going to try it. Or we don't even pass any parameters. And the way we do that is we set a default value. So we say seconds is going to have a default value of 0 if we don't pass it as a parameter. So let's see if that works. And it does, right? Because our difference here is those 46 seconds, right? So if we go back up to the code, and sorry for the back and forth here, I don't have the split screen on here, right here. But basically, I've declared that as a default value. Now, if I declare that guy as a default value, and that guy as a default value, and that guy as a default value, then I go down to the bottom, and I remove the comments from all of these. Let's see if we get it. And you can see it works all the way down. Okay. So this is a clever method to declutter your code, to avoid passing parameters that aren't needed. This is common in complicated library function calls. You'll see this a lot. For example, I'm doing some IoT programming on an ESP32 system, and I'm sending messages, over the air using the MQTT protocol and the HTTP protocol. And there's different ways that I could call these functions with and without various parameters, and those are default parameters if I've not used them. Okay. However, parameters must be in order. Any left out parameters are from the right to the left in the parameter list. Okay, in other words, if I look at this second example, this is always days, this is always hours, and this is always minutes. If I want to leave minutes out, but not seconds, I can't. There's no way to do it using this method. That's a more advanced method. How you can pass any number of parameters in any order, that's a more advanced method, and we're not going to cover this in this class. Some of you might be thinking about how you might want to do that, but we're not going to cover that in this class. Useful? I don't use it very much. I mostly only use it if I'm calling libraries functions that don't need all the parameters. And sometimes even then I include them because it can help with readability. It depends on the situation, which you're getting tired of hearing me say that, I'm sure. Okay, last topic here. We're going to talk about overloading functions. All right, overloading functions. This is an advanced topic. All right. In the book, the example that's shown with function name overloading, the first one is around dates. And what it's showing here is I have a function called print date, a call to that function, and a call to what looks like the same function, right? You see they're both named the same. But the second parameter is a different data type. Okay? And so how does that work? Because just to be clear, if I go up here and I create a second parameter, I'm going to pause for a moment. All right, sorry about that. Hopefully that pause wasn't too much of a glitchy thing here. Had somebody come into the house and the dog's barking here. I copied my function here. I run my function, I get an error. I get a redefinition. Okay. It's like I could use this as my example, but I'm going to use it. No, we're going to use this example. I'm going to change this on the fly. Okay. So if you go back to here, it's like, wait a minute, I have a function, print date, and another function called print date that are the same. How does that work? Okay. So I'm going to create a second, getting late, can't type, circle geometry function that takes radius. No, this is a bad example. No, we're going to do it. That returns only ints, or that calculates only ints. Maybe that's okay, right? You know, you don't need the double precision here. Okay. So we're going to change this to int, and we're going to change this to int. Okay. And so if I go down to my code where I've done my circle geometry, and I paste the exact same code, but I have my circumference and my circumference and area variables as integers. Let's see what happens. I'm winging it. Hopefully this works. Okay, so this still worked as expected. And now check this out. I did integer calculations only of my areas and my circumferences. Maybe that's okay for what you're trying to do. But if you look, this code, lines 162, 63, 60, that's the same. I'm calling the exact same function. But the compiler is smart enough to say I'm going to call this or this based on the data point, the data types that are coming in. Okay, so this is illustration of function overloading. The sample code uses a different example. Okay, so I'm going to make a note here. The video used the circle geometry instead of this example. The example I had was a contrived, silly example. I like this example better. Okay, so this is an example of overloading functions. The danger of overloading functions is if we go back up to the functions again, I'm duplicating code, and you've heard me say duplicating code can be dangerous. If these are way more advanced calculations, it's likely these two functions are calling those calculations separately, and you're okay. Okay, and so overloading can be super helpful. I showed you quickly the date thing. I'm going to bring up Microsoft Excel here kind of as a final example to show you. You can do it. My computer is tired. All right, we're going to bring up a new it's going to give an example here. Those of you that have used dates in Microsoft Excel know what a pain in the ass this can be. Okay, so there's a function called today. It gives me today's date. Okay, I'm going to copy it to a few cells here. I'm going to go in here and I'm going to format it. I'm going to pick a different date function. I'm going to format it. I'm going to pick a different date function. How many can I find? I think there's now those are all unique, right? 1, 2, 3, 4, 5, 6, 7. By the way, I could take all these guys and I can do the European version, right? Which would be 4-6-2024. 6 dash. I'll just type in some more. Oh, can have. Oh, I converted it. Dang it. 6-4-24. 4-6-24. Europe. Right? I can go. I mean, we could probably we can come up with a bunch. Okay. Now, write me a piece of code that calculates if I type a date in whether it's legal or not. Because we got two interesting problems with dates. One is we have formats. There's a million of them, right? And the other problem with dates is we have validity. Okay, so for example, that's not a valid date. 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 And I can go on and on and on. And so, especially, like, is that a valid date? Or is that a valid date? Some of you will remember all your leap year rules and some of you won't, right? Divided by 4, except, right? And so the last thing you want to do is like be checking that the month is between 1 and 12 with all these different formats. Your better bet is to convert all these formats into a single format. And the way you would do that is using function overloading. And then you convert everything into a single format, and then you do all your validity checks on the single format. So there's a really good example of what the function overloading might get you in the end. All right, we are done with what I wanted to show here. I'll get this code up on the screen. Get this code up on the web here for you. And reminder on the deadlines. And good luck with the final push on the class. Keep me posted here on help needed, etc. And perhaps we'll see a couple of you in the next class. Talk to you later.